Hey TechnoStuds, in this video, we're going to use Wireshark to take a look at the sequence numbers. I already captured the data that happened between my demo laptop and my demo Pi, so let's take a look at that. So the first few packets between these two devices, the demo laptop and the demo Pi, is just the establishment of the TCP connection. But we want to bypass that. I'm going to go straight to where it makes the first request. So this is packet 11 here in the sequence is the get command to get the web page for the demo laptop from the demo Pi. So what we're going to do is we're going to take a look at the sequence number. To see that, I'm going to open up the TCP connection of this packet, and we're going to take a look at these sequences. As I mentioned in the prior video, these are the actual sequences right here. This is the raw data. So if you actually look at the ones and zeros, this is the sequence number. It randomly generates it, which is why we see a very large number here, and then it goes up according to what we're going to discuss right here. But for the interest of this video, I think what we're going to do is we're just going to look at the relative sequence number, this one. And so what they've done is they said, rather than take a look at this really large number right here, we're going to simplify it and present it in a very simple form. We're going to start at 1 and we're going to count the way up from there. So this is the number that we're going to look at to analyze this data. We see that this sequence starts at 1. Then let's scroll down just a little ways and see what is in the TCP payload. So the TCP payload, this starts at byte number 1, is the first byte of the TCP payload here, and then it goes all the way up to 428 bytes. So the last byte is the 428th byte. So in our next TCP header, what we're going to see that it's going to start with 429. And if we scroll up to this top part section again, it says next sequence number 429. So here again, this is not data that is found in the TCP header, but Wireshark is giving this to us as a way to view into these packets. So once again, we're starting with byte 1, and this particular packet is delivering from byte 1 to byte 428, and then the next packet is going to start with 429. So let's take a look at the next packet. What I'm looking for is the next packet that's coming from 10.1.0.14, which is my demo laptop, and going to 10.1.0.3. So if I look at this, packet 14 is the next one that I want to look at. And sure enough, our sequence number here is 429 right here. And I look down at the payload, and this doesn't have payload information. And the reason is because there is no payload for this. I'm going to shrink this data right here, or the field right there, and we see that it just ends with the layer 4 and doesn't, so it's continuing on this TCP connection, but it's actually not transferring any data. And so there's no payload. So it makes sense that if this is 429, where do we have our sequence numbers? I opened the wrong layer here, so I'm going to open this up. If this is sequence number 429 with no payload, then it makes sense that the next expectation, the next sequence number is going to be 429 again. All right, so let's take a look at the next packet again. We take a look at the next packet, and the sequence number once again starts with 429, and the payload is 365. So this is byte 429 to byte 700. Well, let's actually look at it. I'm going to pull up a calculator, and we're going to add 429 plus the payload length, which is 365. So that comes up with 794. So our next sequence number is going to be 794. All right, so now let's take a look at our next communication that goes out. So it looks like it's this one right here, although that's going to a different address. So the ones between this is packet 19, and we see the sequence number is 794, which is what we said it would be. And is there a payload? There's no payload here. So the next sequence number will be excuse me, I actually highlighted the wrong one because it's the same number. This is the sequence number of this. Since there's no payload, the next sequence number is 794. Let's take a look at what it looks like from an acknowledgement standpoint. So I'm going to scroll up to the top here, go to our first packet that we looked at, which was the sequence number was 1. And this had a payload of 428, so the next sequence number is 429. Let's look at the return traffic that's coming from the demo pi. So I look at that, and it says the acknowledgement number is 429. So what this demo pi has sent back is, the next time you send me a packet, I'm expecting 429. And in this case, it makes sense because there's no traffic that has been dropped. And so we see all the traffic, everything looks good, and it's expecting 429 as the next sequence. So then we can click on this next communication is happening again from the demo pi to the demo laptop, and it has not changed at all. So we see the acknowledgement number is still 429. And then we're going to, let's take a look at this packet 15, which is going from the demo laptop to the demo pi. Its sequence number is 429, but it figures the next sequence number is going to be 794 because of that payload. So the acknowledgement number of the return traffic, so this is coming from the demo pi to the demo laptop, is the acknowledgement number is 794. So it's recognizing that that is the next packet. So if this still said, in this case right here, if this, let's see, if the last number it had was 429, and so if this said the acknowledgement number of 429, it replied back with acknowledgement number of 429, then the other machine, the demo laptop, would realize that this packet didn't make it, to that device. And so the demo laptop will recognize it didn't get to the device, I need to resend this. And that's how that acknowledgement number works, is that then the demo laptop will then resend that information. Hope you're enjoying the videos. If you like them, could you hit that like button?